This video is going to go over some more complicated examples of solving systems of linear equations using elimination. If you haven't already watched the Khan Academy video about the basics of solving by elimination, please go back and watch that one first. That video really introduces what elimination is. This video is going to go over more examples, assuming that you already know the basics of elimination. So we'll get started with our first problem up here, in which the first equation says 8x plus y equals negative 16, and the second equation says negative 3x plus y equals negative 5. In most elimination problems, we're lucky enough to have something where the coefficients of the variables are going to cancel out easily. So for example, if we had 2x plus y equals 4 and negative 2x plus 3y equals 5, adding this equation, the second one, to the first one would immediately cancel out 2x and minus 2x, and we would get 4y equals 9. That's not always, however, going to be the case when we're working with elimination. In this first example here, we have 8x plus y equals negative 16 and negative 3x plus y equals negative 5. So the 8x and the negative 3x, if we added those together, would not cancel out. We would get positive 5x. Additionally, if we did the y here plus the y here, we would have a total of 2y, again, not eliminating a variable. So we're going to have to do a little bit of manipulation of these equations before we can do elimination. I'm going to take the y terms because they have the same absolute value coefficient of positive 1, and I'm going to change it so that the coefficient in the second equation is actually negative 1. To do that, I would need to multiply this term by negative 1, and if I want to multiply that term by negative 1, I have to multiply the entire equation by negative 1, so times negative 1. Well, negative 3x times negative 1 would come out to positive 3x, plus y times negative 1 would come out to minus y, and negative 5 times negative 1 would come out to positive 5. This equation now, 3x minus y equals 5, is the same equation as before. Now it's just had the same thing done to both sides of the equation, which is that we multiplied by negative 1. And we did that so that now when we add the second equation to the first one, 8x plus 3x will become 11x, but positive y minus negative y will cancel out. And we'll get plus 0, which we don't really need to write, but I'm going to write it there to indicate that we know that we're canceling those terms out. Negative 16 plus 5 is going to get us negative 11. So we have that 11x equals negative 11. Dividing both sides by the coefficient of x, we get x left by itself on the left-hand side. Negative 11 divided by positive 11 is negative 1. So x equals negative 1 in this case. And that's not the only thing we were solving for. We also need to know the y value of the point that would make 8x plus y equals negative 16 and negative 3x plus y equal negative 5 true. So we can plug it into either equation. I'm going to do the first one. 8 times negative 1 plus y equals negative 16. So negative 8 plus y equals negative 16. Add 8 to both sides, and y equals negative 8. That means that our answer is a coordinate point, negative 1, comma, negative 8. If we graphed these two equations that we started with, they would intersect at the point negative 1, negative 8. Let's look at another example where the coefficients don't line up perfectly. So in this case, we have negative 4x plus 9y equals 9, and x minus 3y equals negative 6. So now not only do we not have any where they immediately cancel out, right? Negative 4x and positive 1x aren't going to cancel out. Plus 9x and minus 3y, plus 9y and minus 3y aren't going to cancel out. So in order to eliminate a variable here, we may need to do something a little more complicated than we did last time. Last time, all we had to do, if we refresh our memory, all we had to do last time was multiply the entire second equation by -1 because the absolute values of the coefficients of the y's were the same. It was +1y and +1y. So if we changed one to a negative, they canceled out. Now in this case, we don't have anywhere the absolute values are the same. Here, a -4x, a +1x, right, their absolute values aren't the same, and the same with 9 and 3. So the second thing we look for, in addition to looking for maybe if the absolute values of the coefficients are the same, the other thing we look for is multiples. Here, 4x is a multiple of 1x, okay, and 9y is a multiple of 3y. 9 is 3 times 3. And I'm going to use that one because I'm multiplying then by 3. Instead of with the x's, I would have to multiply by 4. So let's work through this and see why this works. I'm going to multiply this entire equation by 3. So if I copy down the first equation again, and now I'm going to copy down the second equation, having transformed it a bit. Right? It's going to be the same equation in terms of equality to the first one, but it's going to look a little different. So if I multiply this term by 3, I'm going to get positive 3x. If I multiply this term by 3, I'm going to get minus 9y. And if I multiply the last term by 3, I'm going to get negative 18. Now maybe if you didn't see it before, you see why multiplying the second equation by 3 is going to help us do elimination here because now the positive 9y and the minus 9y are going to cancel when we add these equations together. Negative 4x plus 3x is going to get us negative 1x. Positive 9y and negative 9y are going to cancel out. And 9 minus 18 is negative 9. So dividing by -1 on both sides, I find out that x equals positive 9. I'm not done yet. I'm not going to box that as my answer because I need the entire coordinate point that goes along with this. So now I need to plug 9 back into one of these equations, and I'm going to plug it back into the first one because then I don't even have to multiply it by a coefficient. So 9 minus 3y equals negative 6. I'm going to subtract 9 from both sides. On the left, that cancels. I get minus 3y equals negative 15. Divide by negative 3 on both sides, and I get that y equals positive 5. Again, I'm not boxing that because that's not my final answer. Our final answer is the coordinate point 9, 5. X equals 9, y equals 5 is our final answer. Let's take a look at a third example here. We're actually going to combine what we did in the last two examples to solve this one. We have 5x corresponding to 10x, and we have positive y corresponding to negative 7y. Okay, and that's equal to 9 in the first equation and equal to minus 18 in the second equation. So we want either the x terms or the y terms to have opposite coefficients. Okay? So for example, in the y terms here, we would want positive 7y and negative 7y. Or we could also use the x terms, and we would need, if we left the 10x alone, we would actually need negative 10x to cancel out with that. Now we're actually going to do it both ways because knowing how to do this is important because you're not always going to have an ideal situation where you can just multiply by something like positive 7. So I'm going to do the 10x way first, and then we'll look at the 7y way as well. So if I wanted to get 5x plus y equals 9 to have a negative 10x term there, not only do I need to multiply by 2 to get up to 10, I actually need to multiply by negative 2 to make this a negative 10x. So I'm going to get negative 10x minus 2y equals negative 18. And I'm going to add that to the second equation, which I haven't changed, which is 10x minus 7y equals negative 18. So if I add those together, negative 10x plus 10x, thankfully those cancel. Negative 2y minus 7y is negative 9y. And negative 18 plus negative 18 gets us negative 36. Dividing by negative 9 on both sides, we get that y equals positive 4. Plugging that back into our original equation, 5x plus 4 equals 9. 5x equals 5 because I've subtracted 4 from both sides. So x must equal 1, dividing by 5 on both sides. So using the 10x term and eliminating x, we found that the answer should be x equals 1, y equals 4. So let's see what happens if we do it the other way, multiplying the first equation by 7 in order to get this to work out. So 5x times 7 is 35x plus 7y equals 9 times 7 is 63. We still have 10x minus 7y equals minus 18. We're now going to add these two equations together. 35x plus 10x is 45x. The y terms cancel because positive 7 and negative 7 cancel out. And then 63 minus 18, well, 63 minus 20 would be 43, but we haven't gone quite that far. We've gone 2 less than that, so we're actually at 45. Dividing by 45 on both sides, thankfully we determined that yet again, x equals 1, and if we plug in 5 times 1 plus y equals 9, we get that y should equal 4. So our answer is correct that we got from doing it the other method, 1, 4. X equals 1, y equals 4 is the coordinate point where those two lines would intersect on a graph.